Hello and welcome. I am Joe Onisick, and I appreciate you joining us here for this episode of Tech Deck Karaoke. We are joined by our esteemed judge, Sabrina Schaefer Esquire, and our guest, Dave McCrory, who I will allow to introduce himself so that I don't butcher it horribly.
Hi, I'm Dave McCrory. I'm the Global Head of Insights and Analytics at Digital Realty, and I'm also the coiner of the term data gravity.
We have talked about data gravity quite a bit in some of the other Tech Deck Karaoke sessions, so that's awesome. Dave, for posterity's sake, would you mind confirming that we have just received these slides and have no prior prepping on the slide deck?
You absolutely have just received them and have seen only the cover slide and nothing else.
Perfect. And Sabrina, can you confirm this for the federal judges that we'll be asking at a later date?
Absolutely. Absolutely. Confirmed.
Thank you very much. And are we all ready to talk through Dave's presentation with my extreme knowledge that I will be gathering as we go?
Can't wait.
Let's bring up these slides. So this presentation is on fat pipes. I like fat pipes and I cannot lie. And we're going to talk about how those fat pipes apply. In this case, we're primarily talking about pipes as they apply to applications and data traffic, I'm assuming. When we look at data, data has an interesting life of its own. We have a concept that Dave coined called data gravity, where as we place more data in any given environment, it creates an attraction that pulls in the applications and services. So if you think about this from a cloud perspective, as I put more data into AWS S3, the likelihood of me placing my applications and services near that data in order to get the best latency and cost results are very high. So that data creates its own gravitational pull that can cause its own challenges. We also have some other orbital thing going on in the top right, which I have no clue what I would say to about that. And then finally, analytics, services, and software as a service all orbit externally around that first orbit of apps and services. So we end up with this solar system created by the big blob of mass known as data. Isaac Newton was the first to coin this relationship between data and the cloud. We also have this concept of AI robots trying to take over mathematical education. Harvard, Stanford, MIT are all facing problems with robots walking in and taking over the conversation for professors because honestly, they're better at it and a little less dry in their delivery. We're trying to avoid this as we move forward with data and data analytics because this is an extremely processing intensive application that often needs specific requirements from a concept of bandwidth and latency when accessing that data. When we're making huge calculations on large data sets, we're going to need to be able to access that data in its enormous size, but also with the right speed and latency.
Or it could be talking specifically about machine learning.
Or it could be that. But what would Dave know about his presentation, really?
Sure, of course.
I just love that if a robot was taking over, that they would be using a chalkboard and manually writing out on chalkboard, the equation. That's
a little background. These slides were chosen intentionally as things where I Googled specific terms and phrases and found the most interesting picture to describe whatever it was. So
excellent.
Fair enough. I feel like I've been set up.
No, not at all.
So as we look at this, we have to assume that there are some access requirements to how we're going to get to these learning and AI algorithms, and how are we going to access that data on those big fat pipes?
Or it could be home automation.
Very well could be. That would have been my absolute second guess, is how does home automation apply into the AI and ML? We're also going to have to imagine dark patterns. If you're not familiar with dark patterns, they're a play off the terms dark matter and dark energy, which are really descriptions for when scientists don't know WTF is going on. So they use the word dark to explain things that their math doesn't explain. So dark patterns are very similar. When we don't know the patterns, we just call them dark and allow our calculations to stay the same.
Sure.
We also have to worry about when AI and ML algorithms decide to start taking out planes, cargo ships, and trains, because that could be very problematic.
Could be problematic in the supply chain too.
Absolutely. When we start to look at how that supply chain is accounting for stocking on the shelf, how those items are moving between points, and how those systems are accounting for inventory being in the right places, things could very easily go wrong, but they could also fire big fat pipes to move all that data, I assume.
Maybe.
The question really comes down to, are we going to stake the vampire or eat a steak? And that's the question we all have to ask ourselves, because it's extremely subjective. Do I want to end this evil creature, or do I just want to have a great meal if I'm a carnivore type?
So how does that tie into any of this? Just curious.
I mean, it's a high stakes data fat pipes game here. That's how that ties in.
Wow.
Sure. Or we could be talking about Ethereum.
We could be talking about Ethereum, which was my fifth guess.
Yeah.
What it all breaks down to is DAO. And I really don't need to explain that any further, because we all get that.
Or it could be a distributed autonomous organization.
That makes a lot more sense than the thing I said. Finally, as we're drawing all of this data through our DAO, we have to remember our chi, and we've got to align that chi very carefully on those fat pipes. Otherwise, we have problems with our chi.
Or you could have problems like Julian Assange does, where it looks like he's going to end up being extradited to the US.
Another big problem. Sometimes even a bigger problem than chi.
Very much so. He's going to have to keep his chi if that goes down.
So all in, what we really need to focus on is how our pipes are going to affect our AI and ML across individual industries as we begin to apply these algorithms more intensely to help enhance the way we do business.
Sure. Whatever that combination of words turned out to mean.
All right, Dave, I think I probably nailed it. Like if we're looking at a 1 to 10 scale, I'm probably in the 26.7 range, but I tend to be biased.
Yeah, well, I can understand. We all have biases, so definitely makes sense. I'd put it slightly lower than that, but I'm biased too.
Fair enough. So Sabrina, any thoughts, comments, concerns, or feedback?
I don't think the audience learned one thing out of your presentation. I really can't think of one piece of information we'd be able to use outside of I will say the stake comment, high stakes. I'll give that to you. That was pretty good. But 1 to 10, I'd give you an yeah.
Oh, fair enough. I got an. So if they didn't learn one thing, then at least I'm consistent, right? So I've got that going for me.
That's right.
Good point.
All right, Dave. Could you please enlighten us on fat pipes and how they apply to our world?
Sure. So this presentation really doesn't have a title. This was simply the first slide. The idea was this not to be a linear presentation, but to just be a series of topics tied together to educate everyone. So unlike most things, since this is to just present, why does it have to be linear and follow a specific topic in a specific way? So instead, I chose to cover things that I've been looking at and working on. And since I haven't really been talking a lot or anything else as of late, I thought it would be fun and interesting. The fat pipes specifically I've been looking at things around bandwidth and relationships between bandwidth and latency. That has to do a lot with data gravity, but it's interesting when you're looking for images for fat pipes, and you look for things like glass, which most fiber is made out of glass, and you look for glass pipes, and it turns out that doesn't return any valuable results on Google, at least nothing that I thought would make sense to post here. But the actual term fat pipe, it turns out, is a term when you have a really big bandwidth pipe, but there's a large amount of latency. And so what happens is a large amount of data ends up in transit on that cable at any given time, whereas most cables don't have a large quantity of data moving across them. And it's because you just keep putting more and more data on, waiting for it to travel across, and then for the responses to come back. So there's a lot of data in transit at any given time. And that's actually what a fat pipe is. And that then ties with the next slide, data, and therefore data gravity. These are some interesting images. I searched for data gravity, and these are fascinating things that came up all under data gravity. So feel free to Google yourself for data gravity, and you'll see some interesting slides.
A little safer than glass pipes this time.
It turns out, yes. It turns out.
And you won't be flagged by like the federal government or anything. So win-win.
True,
yeah.
True. Although it's just paraphernalia, it's not the actual. So when you start looking at latency and bandwidth, obviously data traversing, you end up with looking at the concept of data gravity. Specifically, my thinking has evolved with data gravity to be around data as being both activity, or you can think of it as energy, and mass. So mass is data when it accumulates, and energy is when you're producing, consuming, or using it. So that might be processing, creation, etc. of data. And so you could have a high amount of that activity occurring, and that would create a gravitational force or show you that there's gravity there. Or you might just have an incredibly large quantity of data, which would create gravity. Next slide, please. So this becomes really true when we're talking about machine learning and machine learning data sets, which end up getting really large. You need to move them around often. You have to move the models around, or the data, or some combination there. But machine learning is also turning out to be very powerful. It's useful for a lot of reasons. I differentiate machine learning from artificial intelligence. To me, artificial intelligence is where I can have a conversation and ask things to do really complex tasks, and they can all be sorted out with some sort of artificial intelligence. Machine learning is simply the machine picking up on patterns, some that I might see, but others that simply are too difficult for me to see. But the machine is capable of learning those patterns and then presenting them, or allowing me to leverage those patterns that it found. All of that takes a ton of data. So next slide, please. So another interesting thing is home automation, and I've been working a lot with home automation as of late, and I found that it creates a lot of data in a lot of interesting ways. It's also kind of risky if you don't secure it properly. This image I found looking for home automation, and this was the least home automation thing I think I've seen. And this was from a company that provides home automation solutions. How this promotes home automation, I'm unsure. But I am now a believer in home automation as far as it becomes really useful. The data is handy to be able to look at, and I think we're going to see a lot more data created in the home than we have even up to this point. And next slide, please. So dark patterns generate and deter the use of things. So dark patterns have now been renamed as deceptive design. And so I'm sure this has pissed you off many times, Joe. You go to cancel a subscription or something like that, and it turns out that to figure out how to do that, you have to go 35 menu selections in, type in a secret set of keystrokes, and magically your ability to unsubscribe appears. That would be a dark pattern. The dark patterns are created intentionally to inhibit you from doing things. And that ties into data being used to inhibit you from doing things. And those data sets are actually becoming more and more available to people. If you do some Googling and such, you can find lots of what I would call intrusive data sets that exist out there about you, where they are tracking things that you have no idea they're tracking about you, and it falls into the entire deceptive practice. But there's a lot of deceptive design around us and we don't realize it. So I compare the deceptive data that exists that can be used against you or to or is collected from you and you don't realize it, to these dark patterns where things are being done to you that you don't even realize are being done. You're being psychologically manipulated to deter you from doing a task or something else. Next slide, please.
Wow.
Supply chain issues abound for gazillions of different reasons. What is increasing is the use of machine learning and such to figure out and project what is happening with the supply chain to try and better align resources where they need to be. The difficulties with supply chain are predicted to continue for at least another year, and I worry that it could be even longer. I know I've certainly waited for things. I had one thing I ordered that took 9 months to get to me, which I would have never dreamed were possible a few years ago. The interesting thing is it requires a lot of data to do all of this, to do these machine learning projections, and you need to store the data so that you can look for long-term trends. It might be a shipping container, a container ship where you're shipping containers, and not only are they able to track individual containers, the items in the containers, the container ship itself, but they look for patterns of what is the easiest route to take? What are the weather conditions? Will they impact the amount of time for the ship to travel? What is the cost for the ship to travel overall? Obviously, you have prices in diesel and such shifting and changing. They use all of that to build models for looking at not only time, but costs of shipping goods. And that could be by any of these different modes: trains, ships, trucks, or planes, any of those different patterns. Next slide, please. And then this talks about Ethereum. So the OR is built over the symbol for Ethereum, and the stakes. If you don't follow what's going on in the world of cryptocurrency, Ethereum is one of the things built around the idea of Bitcoin, cryptocurrency, and Ethereum right now is using something called proof of work. And what that really means is you have done the work to find the magic Ethereum token that has value, much like you hear about Bitcoin miners. That's their current model. They are moving to a new model called proof of stake, and that's where the stakes come in. The proof of stake model is driven off of you have X number of Ethereum tokens, and that shows that you have a stake that's involved in doing trading in the exchanges. No one's sure how it's all going to work out. I do not have a mountain of money in cryptocurrency or anything else, so I'm certainly not promoting it. But it does turn out to consume a lot of power, and it means more data. And it turns out that even cryptocurrency tends to accumulate and follow data gravity principles in Bitcoin wallets or the equivalent. And it also becomes a big target for people trying to steal that data and pull it out. So another interesting angle. Next slide, please. And following that same pattern are these distributed autonomous organizations, which use tokens and allow people to run everything as large as a company as independent voters that simply have tokens that allow them certain rights and abilities. And all of the things that are done with these organizations are done on smart contracts, where they modify and operate things all on a blockchain. This is another trend. Again, more data, because now every exchange and everything that's happening in the company is all being automatically put onto a giant blockchain. It is another fascinating development. We'll see where that goes. And finally, the last slide. And finally, Julian Assange, who it looks like is going to be extradited, but has been responsible for creating a ton of different privacy schemes and approaches to try and protect people from putting data out there into the open, often where it should be when it's been held from us and kept secret, kind of deceptive, etc. More of that happens, and as it does, it seems to occur on specific sites or with specific groups. Again, that clumping together in that data gravity pattern, but much more of a risk to some people than others, including Mr. Assange. That's it.
Very interesting. So we're looking at data as a whole, how it applies to all the changes around the world and in the industries, the data we see, the data we don't see, and the data being collected, compiled, and learned about behind the scenes or in front of the scenes.
Yes, absolutely.
So you were close, Joe. You were close.
I'm so close.
Just by that much.
That's actually the title of my book. When I do my
your memoirs, yeah.
Excellent. So if you could have the audience take away kind of one big ticket item from this, what would that big ticket item, what would that concept be?
I would say the concept would be look at where data accumulates and where data is created and how it's consumed. Those are kind of the interesting things to be aware of that are happening. And as you follow those trails, you unravel a lot of things that if you don't know to look, you're unaware of what's happening. Much like if you drive your car, but you never ever open the hood or look anywhere in the car or the trunk, you may not be aware of all of the things going on. You can drive the car, you can get from point A to point B, but you're unaware of all of these other things that exist. The same is true with your data.
It's really interesting. I always like the idea of just being aware of the data you're creating and the information you're giving, right? One of my favorite examples is a Nest video camera doorbell, right? I'm putting this on there for some convenience for me, but if the police or law enforcement subpoena that information, I've just waived my Fifth Amendment rights by providing witness to my own life.
Yep, that's right. Which is why I keep all of my stuff encrypted locally and don't store it anywhere on the cloud.
Absolutely. And it's so easy to become unaware. You know, I know people who are, the tinfoil hat types that walk around with 15 customer loyalty cards in their pocket. I'm like, you're intentionally tracking everything you do while being worried about the government tracking you?
Yeah. And you save 15 cents on that, on that Charmin.
Right. Yeah, I always wonder, did you save 15 cents or did they just upcharge me 15% or 15 cents for not being loyal?
I think probably both. They're going to double dip when they can, right?
Absolutely. Well, that's awesome. Well, Sabrina, I think it now comes down to you to give Dave the bad news that I obviously presented this better.
Yeah, well, I mean, it's a close tie. No, I'm just kidding. Not even close. Not even close. I will say, there's some really fascinating topics that you're interested in. I could see why they're kind of top of mind for you. I can't wait to dive into the dark patterns. I think that's incredibly interesting and how that's kind of navigating and shaping behavior and interactions and expectations. So really neat. Joe, let me see. What did I learn? I was impressed with your tie-in with Newton being the first person to coin data gravity. That's hilarious. But I have to give this one to Dave. Congratulations. Congratulations. You got a big prize coming. Just you wait.
I bet.
Well, Dave, that was absolutely brilliant. And if people want to find you more of kind of like your research or thoughts on how this plays out, where can they do that?
Best place is Twitter, just my last name, is my Twitter handle. So super easy, at McCrory.
Excellent. Well, you should definitely follow Dave. They're on Twitter. Dave's got a ton of experience in this industry, a huge background, and comes up with a lot of interesting concepts, data gravity being one of the ones we kind of mostly know about, or all know about. Thank you very much, Dave. Thank you, Sabrina, for nothing.
I'm glad I could help. I'm glad you could. I think you're 3 for 3 now, or 0 for 3. 0 for 3.
Thanks, Joe. Thanks, Sabrina. I appreciate it.
See you later. Bye.
Bye.